Find the magnitude of the resultant of the three vectors A, B, and C. Give this problem a try and keep watching to see the solution. We'll resolve the vectors into their x and y components. C is already in the positive x direction and B is in the positive y direction, but A is neither purely x nor purely y. So let's resolve A into its horizontal and vertical components. From the orientation of A, it's clear that it's going to have a negative x component but a positive y component. We'll use trigonometry to find these components. One of them will be 5 times cosine the angle, and one of them will be 5 times the sine of the angle. To know which is which, you can always complete the right triangle, but the way I like to do it, and it's perhaps a memorized pattern, is if the angle is with the x-axis, then the x component will take the cosine. If the angle is with the y-axis, then the y component will take the cosine. In this case, the 105 degrees is with the x-axis. So it is the x component that will be 5 cosine the angle. The y component will be 5 sine the angle. Okay? 5 cosine 105 degrees is around 1.29. It's negative because it's the cosine of an obtuse angle, but the negativity is already shown with the direction of AX being to the left. The vertical component works out to be 4.83. And now we can add the respective components. The vertical component will be 2.12 from B plus 4.83 from the y component of A, and the horizontal component will be 2.12 from C minus 1.29 from AX. Doing the addition, we get 6.95 for the vertical component and 0.83 for the horizontal component. And now we can find the magnitude of the resultant by applying the Pythagorean theorem. This works out to be 7.0. So, the resultant vector of A, B, and C is approximately 7 units long. Could you figure it out?